So you're in calculus, and you see a question about velocity, and you get excited because, yay! You know physics.
But you're not here.
You're here, and now you have to use your calculus brain to do the physics.
Luckily, you remember everything you learned about velocity and acceleration, and now you know how to do derivatives, so you're all set. You know that the change in position is velocity and that the change in velocity is acceleration. In calc terms, they're derivatives. The derivative of position is velocity. The derivative of velocity, the second derivative of position, is acceleration. So if you have an equation like this one,
S of t equals 2x to the third plus 4x squared plus 3x plus 5 for position, and you take the derivative, you get this velocity equation. S prime of t equals 6x squared plus 8x plus 3, which can be rewritten to v of t equals 6x squared plus 8x plus 3. And the derivative of that equation would be v prime of t equals 12x plus 8, which is the acceleration equation.
For the object we originally just had the position equation for. With this knowledge, you can use any of these equations to get the other one using derivatives or antiderivatives. So if we have this position equation, the position at t equals 5 is 25, and we want to know what the velocity is at t equals 5, and we get the and then we do the derivative of the position, and we get the velocity equation. So s prime of t equals v of t, which equals 3t squared minus 30t plus 54. And then we plug in 5, and we get negative 21. Now this problem might come up again, so remember it for later. Now on to another part of calculus that we learned about in physics, integrals. In physics, we know integrals as work. Integrals can be used to find the displacement of an object, which is the integral of the velocity. And we also can find the distance an object has traveled by finding the integral of the absolute value of the velocity.
So next time you find yourself stuck on a problem, just remember you have physics and calculus on your side.
So would that mean you'd be calculus?
Remember that problem I told you to remember earlier? Well, here's the extra tidbit. Since the velocity is negative, we know that the object is moving to the left.
we funny. You get the
Alright, and should I zoom in on it? Or like, no. Okay, cool.
How weird did my hands look going like?
Now, wasn't that video just integrate?